Section 9.3 is on solving linear systems by adding or subtracting. So we are going to use what's called the elimination method for this section, as well as section 9.4. You can simply add or subtract, or you could also multiply and then add or subtract. So for today and tomorrow, we are just going to stick with just adding and subtracting. We're not adding in that extra step of multiplying. So the elimination method is where one variable is eliminated by adding or subtracting the two equations of the system. So for this one, if we turn this into an addition problem and we add, going straight down, add the x's together. So we'd have 4x plus 1x is 5x. And then negative 2y plus 2y would be 0. So that's gone. Bring down our equal sign, and then 12 plus 8 is 20. And then we would have to divide both sides by 5 since that is multiplication. X would equal 4. So when we're solving a system, remember, we're looking for that ordered pair where they cross, and we just figured out pretty quickly that X was 4. And then this second step is just the same as if you were doing substitution. We have to plug that back into one of our original problems. So I'm going to choose the bottom one, and I'm going to do 4 for x plus 2y equals 8, and then I'm going to subtract 4 from both sides, and then have to divide both sides by 2. So y would be 2. So this system, the two equations would cross at 4, 2. Now for this one, if you notice, the x's have the same coefficient, but they're both positive. So if I added that, I would get 4x. If I look at the y's and I added going down, I'd have 6 and then minus 1, that would be 5. So neither one of those would cancel out. So we're going to have to subtract onto this one. So 2x minus 2x would cancel out then if we subtracted. So that's exactly what we wanted to do. And then we would have 6y minus a negative y, which would turn into 6y plus 1y would be 7y. And then 6 minus a negative 8 would turn into 6 plus 8. So that would be 14. And then we could solve our equation by dividing by 7. So we would know that our y is 2. And then we can plug that back into one of our originals, and we would have 2x minus 2 equals negative 8. Add 2 to both sides. Negative 8 plus 2 would be negative 6. And then divide by 2. So x is negative 3. So these two equations, the system crosses at negative 3, 2. The other thing that I could have done with this is that instead of subtracting, I could have gone through and made everything opposite and then added. If I do that, I'm still going to end up with the 7y equals 14. So whichever way makes more sense to you, if you want to just think about it as subtraction, or if you want to change everything to opposite signs and then add, they're both fine and they both work. All right, for this one, I notice I have a negative 4x and a positive 4x, so I can add because those are going to cancel out. And then going over to the y's, I have a negative 2y and a positive 2y. Those would cancel out as well, so nothing is left on that side. So we have a 0. And then 4 minus 4 here, 4 plus a negative 4 is going to be 0. So we have 0 equals 0, which is a true statement. So this is infinitely many solutions. That means they cross at all points because they are the same line. All right, and then this one, I noticed that the 4's, the x coefficient, are the same, and the y coefficients are the exact same. So I can subtract, or I can add and just go through and make everything opposite before I add. So 4x plus a negative 4x is going to be 0. Negative y plus a positive y is going to be 0. So everything's going to cancel out here. And then I have 3 plus 2 over here, which would be 5. So 0 equals 5 is not true, so this is a no solution. And then for our last example here, it says that Best Backyards is building a rectangular deck for a customer. The customer wants the perimeter to be 40 meters and the difference between twice the length and twice the width to be 4 meters. What will be the length and the width of the deck? So if they want the perimeter to be 40 meters and it's a rectangle, so we have length and width. If we added those up, we would have 2 L's and 2 W's. So 2L plus 2W is going to give me 40. And then he says that the difference between twice the length and twice the width, so the difference means we're going to subtract these, is going to be 4. What will the length of and the width of the deck be? So now we have to use this to solve our system. So the coefficients for the L's are the exact same, but the coefficients for the W's, one's positive, one's negative, and they're both 2's. So that's good. I don't need to change anything. I can just add. So 2L plus 2L is 4L. The W's are going to cancel out, and 40 plus 4 is 44. And then I have to divide by 4 on both sides. So L equals 11. So the length is 11 meters right now. And then I'm going to plug that back into one of the originals. So I'm going to use the bottom one. So I'm going to have 2 times 11, oops, not plus, minus 2W equals 4. So that's 22 minus 2W equals 4. So I'm going to subtract 22 from both sides. Remember to bring down that negative sign with that 2W. Oh, goodness. And 4 minus 22 would be negative 18. And then we'd have to divide by 2, by negative 2. And we would get a positive 9. So our width would be 9 meters.